Hello, let's talk about parallel circuits and current divider. So we have our circuit here. We have resistor 1, resistor 2, resistor 3. Then we have ammeter 1, ammeter 2 and ammeter 3. As you can see there. So we have this current 1, current 2, current 3. Then we have the current that is entering, that's I. So as we know, current 1, having known the Kirchhoff's current law, we know it is equal to I1 plus I2 plus I3, or we can say I3 is equal to I2 plus I1. So to get I, we have to add all the currents. So we have I, this one, is equal to I1 plus I2 plus I3. That's current 1, current 2, current 3. So we have the voltage across each resistor is the same, or it is equal. In resistor 1, resistor 2, resistor 3, the voltage across all of them is just equal, because you can see this point when you place one terminal of the voltmeter here at this node or this node, you can see it is the same as placing it here and here, and it is the same as placing it here and here, because these form one node. This is what we call nodes, and these two nodes form a single node. It's like one node, because you can see here we have no other element but a short circuit. This short circuit is it's what is connecting the two nodes. So we can say that measuring the voltage across any of these resistor is just the same thing, one and the same thing. So by Ohm's law, we know that I1, that is current 1, this one over here, is equal to voltage, because it is equal everywhere, all over R1. Then current 2 is equal to voltage V, that is total voltage, which is here. This is the voltage supply, plus all over R2. Then R3 or I3, this one, the last one here, is equals to V all over R3. Then this I is equals to V all over V, this V voltage supplied divided by the total resistance, that is RT. So V all over R3, RT, that is this current, the total current, is equals to V all over R1, that is it, V all over R plus V all over R2, as per how we have said up here. This is what we are replacing. So we are replacing V R1 into this, then V all over R2 into this, V all over R3 into this, then this one we are replacing it V all over R total. That is how you get this equation here. So having gotten this one, it's just one and the same thing here. So to get this, or IRT 1 all over R3, we did if you can see, we have V's on top, or the numerators, both numerators are V. So to remove the numerators, we divide all through by V. So dividing by V, we get 1 all over RT is equals to 1 all over R1 plus 1 over R2 plus 1 all over R3. For two resistors, resistance R total is equals to R1 plus R1 times R2 divided by R1 plus R2. That is the product of the two resistances all over the sum of the two resistances. Then let's talk about current dividers, or the current division method. So this is used to find the current that is passing through a single resistor in a parallel circuit. So to find that, let's go through this. So to find that, we can see to find the total resistance, we take R1 multiplied by R2 divided by R1 plus R2. Then V is equal to I RT. That is the total current I, this I, then times the total resistance, which is equals to I. Then we replace by our R total by with this one. So R total is equals to V is equals to, that's V is equals to I multiplied by R total, which is here. So having that, we come here. So if you were to find I2, this one here, if you were to find I2 in this one, what do we do? Because we have the voltage equal all over, we take by Ohm's law, we know that I is equals to V all over R. So we get V, because it's equal here, V all over R2. So that's how we got this. So but we knew, or we know very well, that our V here is equals to I into R1 plus R1 times R2 all over R1 plus R2. That's what we have here. So having that, we can divide it. Divided by what? This one, R2. So dividing that, you get I multiplied by this one. So we because it's division, you multiply by the reciprocal, that is 1 all over R2 into bracket, let's say this R1 times R2 all over R1 plus R2. Then we have this one is the same, just the other side, the R, this one, the R2 is just on the same side where it was. So you find out that I2 is equals to R1 all over R1 plus R2, multiply the current. So likewise, I2, this one here, or I1 here, is equals to R2, isn't it so? Yeah, it's equals to R2 divided by R1 plus R2, multiplied by the current, this current that is entering. So that's how we find the current that is passing through a single resistor, having two resistors in parallel to each other. So thank you for watching. Welcome back again. Like, subscribe, and then comment. To subscribe, you'll be able to get more content like this. Thank you and welcome back.